Hello students, let us prove the theorem of Pythagoras from class 10th maths part 2. Before this we have studied what is the Pythagoras theorem. In this session we are going to prove the Pythagoras theorem. So let us have the statement of the theorem. In a right angle triangle, the squares of the hypotenuse is equal to the sum of the squares of remaining two sides. So as we know, this is the Pythagoras theorem. To prove this we need diagram. So let us have triangle ABC, which is a right angle triangle given. So given will be in triangle ABC, it is given that angle B is a right angle, that is angle ABC is equal to 90 degree. So in this triangle we have to prove that square of hypotenuse is equal to the sum of the squares of remaining two sides. So for this triangle, side opposite to 90 degree is the hypotenuse. So AC is the hypotenuse. So we have to prove that AC square is equal to remaining two sides are AB and BC. So we have to prove AC square is equal to AB square plus BC square. Now to prove this we have to do one construction. We have to draw a perpendicular BD from vertex B to the hypotenuse AC. And by doing this we have got A, D and C are collinear. Let's start with the proof. So in a right angle triangle we have constructed segment BD perpendicular to AC. So by doing this we have got three right angle triangles. So here we have to use the property of similarity of right angle triangles. So if in a right angle triangle, if we draw a perpendicular on the hypotenuse from its opposite vertex, the three right angle triangles so formed are similar to each other. So this is the property of similarity of right angle triangles. By that we had triangle ABC is similar to triangle ADB is similar to triangle BDC. So we have to take these three triangles which are similar for this given correspondence only. That is, we have to take triangle ABC is similar to triangle ADB, which is similar to triangle BDC. So for this correspondence, these three triangles are similar. Now let us consider first two of them, that is triangle ABC is similar to triangle ADB. Now as these two triangles are similar, their corresponding sides must be in proportion. So if we take side AB, its corresponding side is AD. So we have AB divided by AD is equal to, we take first and the third vertex, that is AC, then its corresponding side is AB. So we have AC divided by AB. And this is because these are the corresponding sides. And the corresponding sides of similar triangles are in proportion. That's why we have AB divided by AD is equal to AC divided by AB. Now if we cross multiply, we get AB into AB, that's AB square is equal to AD into AC. We call this as equation number 1. In the same way, now we consider the first and the third triangle similar, that is triangle ABC is similar to triangle BDC. Here also the corresponding sides must be in proportion. So if we take BC, its corresponding side is DC is equal to AC, its corresponding side is BC. So we have BC divided by DC is equal to AC divided by BC. Again the reason is corresponding sides. Here also if we cross multiply BC into BC, we get BC square is equal to DC into AC, equation number 2. We compare what is to prove. We have to prove that on the right hand side AB square plus BC square. So in equation number 1 and 2, as we can see, the left hand sides are AB square and BC square. So here we should take its sum. That's why one operation we must do on these two equations is addition. So we must add equation 1 and equation 2. So adding equation 1 and 2, we have to add left hand sides to the left hand side, that is AB square plus BC square, which are the left hand sides of equation 1 and 2. So we have AB square plus BC square is equal to, now we have to add the right hand side to the right hand side of equation 1 and 2. So the right hand side of equation 1 is AD into AC plus right hand side of equation 2 is DC into AC, that is DC into AC, which is equal to, from these two terms we have AC as a common. So we take AC as a common. So in bracket we have AD plus DC remaining, that is equal to AC into As we can see in the diagram, what is AD plus DC? As A, D and C are collinear points, AD plus DC we get AC. So instead of AD plus DC we can write AC. So as to have AC into AC, that is equal to AC square. So we get here AB square plus BC square is equal to AC square. By rearranging it, we get AC square is equal to AB square plus BC square. So that is we wanted to prove for in a right angle triangle, the hypotenuse square is equal to the sum of the squares of remaining two sides. This is the Pythagoras theorem.